Hello everyone, welcome to my channel. My name is Adam and I'm from Morocco. Today I've got an arithmetic question problem for you that I found in my maths textbook. The question reads as follows: prove that if you add the number 1 to the product of 4 successive whole numbers, you get the square of another whole number to be determined. So, give this problem a try, and when you're ready, keep watching the video to see the answer. So, how are we going to solve this problem? Well, the key when you have a problem that is written as a text is to try to write things in terms of symbols. So, the problem is about product of 4 successive whole numbers. So, I'm going to let these 4 successive whole numbers to be n plus 1, n plus 2, and n plus 3. You can see that these are 4 successive whole numbers because if you add 1 to n, you get n plus 1, add 1, you get n plus 2, add 1, you get n plus 3. And so the question says, if you take these 4 numbers and multiply them together, so you've got n times n plus 1 times n plus 2 times n plus 3. So you multiply them together and then you add 1 to the product. The question says, prove that this equals a whole number squared. So in other words, prove that this formula is a perfect square. A perfect square is the square of an integer. So it's an integer whose square root is also. So how are we going to prove that this formula gives you a perfect square? Well, some people may try to expand this product, multiplying n by n plus 1, you get n squared plus 2, then they multiply by n plus 2, then by n plus 3, then they add 1, and they try to factorize what the formula that they will get. I do not think that this is effective. I think that we should look at this problem from a different perspective. You see, we have a plus 1 at the end of this product. What kind of square has a plus 1 at the end of it always? You guessed it. It's the first remarkable identity. It says that if you have n squared plus 2n plus 1, you can write this as n plus 1 all squared. Or you start from the square and you get to the formula. It's the same thing. So, since we have the plus 1 already, we have to prove that this is actually the n squared plus 2n. Actually, to not confuse stuff, let's here use the symbol m instead of n, just to avoid confusion. So the question now becomes, could you find a value for m such that m squared plus 2m plus 1 is the same as this formula? Well, a key observation here tells you that m squared plus 2m, which is supposed to be the product over here, itself can be factorized. If you factor out an m, you get m plus 2 left. And then plus 1 equals, that whole thing equals m plus 1 all squared. So if you can show that this product is the product of two integers that are separated by 2, then you have solved the question. And now, what could this m be? Well, it may be possible to take a pair of factors here and multiply them out and get 2 plus a product of another pair of factors here. So let's try this out. Let's try n times n plus 1 and n plus 2 times n plus 3. So n times n plus 1 is n squared plus n. Okay, and n plus 2 times n plus 3 equals n squared plus 5n plus 6. So we haven't got two numbers that are separated by 2, at least not clearly. So we've got to try a different pair of factors. Let me choose, instead of n times n plus 1, let me choose n plus 1 times n plus 2 and multiply out. So n plus 1 times n plus 2, that equals n squared. N times n is n squared, plus 1 times n, that's n, plus 2 times n, that's 2n, n plus 2n, that's 3n, plus 1 times 2 equals 2. What are the terms that we've got left? We've got n and we've got n plus 3. So n times n plus 3, which equals n squared plus 3n. And surprise, surprise, if you take n squared plus 3n and add 2 to it, you get n squared plus 3n plus 2, which is this product, which is exactly what we wanted. So now we can rewrite this product n plus 1 times n plus 2. We have just found that it's 2 above this product, that it's n lots of n plus 3 add 2. So we can substitute this formula for this product over here. So now what we get? N lots of n plus 1 times n plus 2 times n plus 3 plus 1, which is the formula we wanted to show is a perfect square. Now we substitute this with this. So what have we got? N times n plus 3, these are the two terms left, times, in big brackets, this, which is n times n plus 3 plus 2. And do not forget the plus 1 at the end. So if I expand out, I get n times n plus 3 times n times n plus 3, that's n times n plus 3, the quantity squared. And then we've got plus 2 times n plus 3. So let me put that in big brackets to be much clearer, and then I have the plus 1. And voila, we want our m. We got the m that we wanted. That's exactly this formula. So m in this case actually equals n times n plus 3, or n squared plus 3n. It's the same thing. So if we go back one last time to our original formula, we can show that this equals n times n plus 3 plus 1 all squared, and this is the same as n lots of n plus 1 times n plus 2 times n plus 3, and that is what we wanted. So this is what we wanted to show. We showed that if we take this product and add 1 to it, you get the square of an integer. So here is our result that we have proven. Now we can write QED. Did you enjoy this video? If you did, please give me a like, subscribe to my channel and ring the notification bell. I will be uploading many more videos in the near future, and do not forget to subscribe to my main channel, Moroccan Geographer. The link will be in the description. If you want to leave me a suggestion for a next video, please do so in the comment section. And as always, until next time, see ya.